listener. This is Akash. Today we'll start our topic of simple mechanisms. For understanding simple mechanism, first of all, let us start with relative motion. Relative motion is defined as the motion of one body with respect to some another body. Now here we are studying about links, so we can say that motion of one link with respect to some another link, and that some another link may be a fixed link or a moving link. So this is the definition of relative motion. For a motion, any system must have two links. Now if we categorize this relative motion, we have three types. First one is self-constrained motion or completely constrained motion, and after that second one is successfully constrained motion, and after that we have unconstrained motion. Now let us understand these different types of relative motion with the help of example. First of all, self-constrained motion. Now I am taking a block in which square cavity is there, and I pass a square bar of same size through this block. This is our first body or first link. This is our second body or second link. Now here let me draw its side view also. Suppose this to be a cubical block, and this is also a square bar. There's something like that. Body 1, body 2. This is body 2. Now here the only possible motion we will get, only possible relative motion we will get is this motion, this to and fro motion. Now this is the good example of self-constrained motion, because here our other motion will get automatically blocked. This square bar cannot rotate inside this, so only one desired motion we will get in this system, that is to and fro motion. So in this, all other relative motion are automatically get blocked. So this is our self-constrained motion. Self-constrained motion. By the way, meaning of constraint is desired motion. Meaning of constraint is desired. Now after this, let's move on to successfully constrained motion. Let us take another example. We'll take same cubical block over here, and we cut a cavity inside it. Now this time this is a circular cavity, and we'll put a cylindrical rod inside it. Let me draw its side view. Now this time it is circular. This is our body 1. This cylindrical rod is body 2. Now here if you observe, we'll get two type of motion. First one is to and fro motion, and second one is it's rotary motion. So actually here in this case it is a unconstrained motion, but if we cut a keyway inside this block and this bar and fix a key so that we can block this rotational motion, then here our desired motion will be only to and fro motion. So from here we can see that we need to block one motion with the help of keyway and key. This keyway and key will help in blocking this rotary motion of this cylindrical rod. So this is not automatically constrained. This comes under the category of successfully constrained motion. Successfully constrained motion. One more example we'll see is, let us consider a piston cylinder arrangement. Now consider this to be our system, and this cylinder is body 1 and this piston is body 2. Now generally we have a connecting rod. This is the common structure of engines. This is our crank, and crank is fixed. Now if we observe this, our system is cylindrical block and piston. Here only one motion is possible, that is reciprocating motion. The rotary motion of this piston is blocked by this connecting rod, but this connecting rod is not the part of the system. So here this is the example of successfully constrained motion. Successfully constrained motion. We constrain this motion with the help of connecting rod. Here we will take help of key and keyway. So in successfully constrained motion, we'll block undesired motion with the help of some external body. Here our undesired motion is rotation of this cylindrical bar or cylindrical rod, and we block this motion with the help of key and keyway arrangement. So key here actually is our external body. In case of piston cylinder arrangement, rotation of piston is our undesired motion. So we block this undesired motion with the help of external body, and this connecting rod is our external body. So for those systems in which undesired motion are blocked with the help of some external body, comes under the category of successfully constrained motion. Again, if we come to unconstrained motion, then already I told you this is the good example of unconstrained motion. Let us consider a cubical block. We have a bore of some diameter, and we put a same dia rod inside it. This side view is something like this, body 1, and this is body 2. Now here to and fro motion is there and reciprocating motion is there. So more than one desired motion we are getting. So this falls under the category of unconstrained motion. Now after relative motion, let's move on to our next topic, which is link. Every part of the machine which is having some relative motion with respect to some other part will be known as link, or sometimes it is also called as element. Let's understand this with one example. Let us consider a mechanism. This generally this is a parallelogram linkage. We'll study about it as we move further in this simple mechanism topic. Now this mechanism generally used in our steam locomotives, in training wheels. So here this link is fixed. I'm showing this motion one wheel is driving wheel here and other wheel is trailing wheel. So this mechanism is used in wheels of locomotive steam engines. So here this is our link 1, link 2, link 3, link 4. Now here link 1 is our fix, link 4 is rotating, link 3 is just a coupling rod, and link 2 is also rotating. Now let us consider this 4 to be a driving link and this 2 will be our driven link. So each and every link in this mechanism will have relative motion with respect to some other link. Now one more thing for link is link must be a rigid body. For a body to be considered a link, it must be rigid or deformation free body. Suppose in those locomotives, if link 1, link 2, link 4 are made of steels and we'll put link 3 made of rubber, then this will not act as a link because it will get deformed, it will not transmit power. So link must be a rigid body. This is the compulsory point for the link. We can take one more example, a belt pulley arrangement. This is our body 1, this belt is our body 2, and this is our body 3. First and third are pulleys and second one is belt. Now here suppose if this pulley 1 and 3 made of cast iron and it is a part of some drill machine or lathe machine and we'll use a rubber band here, then it will be not considered to be a link because its purpose will get killed. So link must be a rigid body. There is no chance of deformation in link. No doubt belts have some deformation, but these deformation are under some permissible limits. Remember these things. Now after this, let's move on to types of link. Now these links are classified into 3 categories. First one is rigid link. Second one we have is flexible links. And third one we have fluid links. Now rigid links. Rigid links are those links in which deformations are negligible. For example, crank, connecting rod, piston, cylinder are good example of rigid link. Negligible deformation we have. Negligible deformation. In flexible links, we have some deformations, but those deformations are under permissible limits. Here in this example, belt is a good example of this flexible link. Some more examples are there, like we have rope. Rope is also a good example of flexible link, or chains sprocket arrangement. These are also a good example of flexible link. After that, we have fluid links. In fluid links, whenever the power is transmitted with the help of fluid pressure, then it acts as a fluid link. Example, in case of hydraulic brakes or any hydraulic machines like press brakes, press brakes. Hydraulic pressure is used to bend sheet metal, or hydraulic shearing machine. In these machines also, power is transmitted with the help of hydraulic coils to the shearing blades, and then shearing of sheet metals will take place. There are much more examples of fluid links, like hydraulic jacks. Hydraulic jack is one of the good example. Hydraulic jack is one of the good example where fluid act as a link, and with the help of this, hydraulic jacks will lift very heavy